Hello, welcome to the video for A-Level Revision Sheet 3. We're looking at trigonometric equations and identities with Year 12 content. So the first thing we're going to do is I've put plots just to remind you of the trig functions. So here on the top right we have cos x, so y equals cos x. Middle is y equals sine x. And then at the bottom we've got y equals tan x. I've plotted all of these just from minus 360 to plus 360 degrees. So they all obviously extend past that, but I've only plotted them to here. Right, so question 1. We're given that angle theta is between 90 and 180, and that cos is negative 2 over 3, and we want to find sine and tan. So we are going to first of all look to find sine theta. So using sine squared theta plus cos squared theta equals 1, which is one of our main trig identities, we know that sine squared theta can be written as 1 minus cos squared theta. But here, cos squared is minus 2 over 3, or negative 2 over 3 squared. So 1 minus negative 2 over 3 squared, as cos theta is minus 2 over 3. So this becomes 1 minus 4 over 9, which is 5/9. So sine theta then is the square root of 5/9, which is root 5 over 3, but plus or minus. So they're both plus or minus because we don't know yet whether it's the positive square root or the negative square root. So since theta is between 90 and 180 degrees, looking at the graph for sine theta, we know that we're going to take the positive square root, because sine is positive between 90 and 180 degrees. So we will take sine theta to be positive root 5 over 3. To get tan theta, we're just going to use our usual identity. So tan theta is sine theta over cos theta. So root 5 over 3 over negative 2 over 3, which simplifies to minus root 5 over 2. And there you have it. Question 1 is done. Question 2 then, we've got to solve 3 cos 2 theta minus 15 degrees is equal to 2 sine squared 2 theta minus 15. The first thing I'm going to think about is working on our domain of solution. So if theta is between 360 and 0, then 2 theta is going to be between 360 times 2, which is 720. 720 and 0. So 2 theta minus 15 will be between 705 and negative 15 degrees. Okay. So let's start by noticing that at the moment I've got an equation in terms of cos and sine squareds. We want to get all of our trig identities in trig functions, our trigonometric functions, to either sine or cos. We don't have an identity that we can use for cos easily, so we're going to change sine squared into cos squared using the identity sine squared is cos squared minus 1, or 1 minus cos squared. So please ignore that little mistake. Right, so we're going to start here. So 3 cos 2 theta minus 15 degrees is equal to 2 sine squared 2 theta minus 15 degrees. Well, that's going to imply that 3 cos 2 theta minus 15 degrees is equal to 2. Sine squared is 1 minus cos squared. So 2 lots of 1 minus cos squared 2 theta minus 15 degrees. So we get 2 negative 2 cos squared 2 theta minus 15 degrees. So we're going to rearrange to get them all onto one side of the equal sign and equaling 0. So we end up with 2 cos squared 2 theta minus 15 degrees plus 3 cos 2 theta minus 15 degrees minus 2 equals 0. And to make our life easier, I'm going to say let y equal 2 theta minus 15. And then we have 2 cos squared y plus 3 cos y minus 2 equals 0. So with that equation, we're going to start by thinking of factorising it into a quadratic. So if we've got the quadratic 2 cos squared y plus 3 cos y minus 2 equals 0, this factorises into brackets 2 cos y minus 1 and cos y plus 2 equaling 0. Hence 2 cos y is equal to 1, or cos y equals negative 2. Now this one here on the right, we know has no solutions since cos y is between positive 1 and negative 1. So using the other one, so cos y equals a half. So if I think about my cos graph, going between a half, I've got a line here essentially. So I've got one here and one here. We also know that y then is arc cos a half. And in the range that we're looking for, remember we're looking between minus 15 and 705. We are going to have 60 degrees, 300 degrees, and then 420 degrees, i.e. the 60 plus the period of cos, which is 360, 420 degrees, and 660 degrees. But I now need to remember that actually y equals 2 theta minus 15. So 2 theta minus 15 is those 4 angles, so 60 degrees, 300 degrees, 420 degrees, and 660 degrees. So I can add 15 degrees to all of those. 75 degrees, 315 degrees, 435 degrees, and 675 degrees. Therefore, giving my 4 possible solutions for theta being 37.5 degrees, 157.5 degrees, 217.5 degrees, and 337.5 degrees. So there's 4 possible solutions in the range theta between 0 and 360. And on this next slide, I've plotted those and the function on Desmos, just to show that we have got the correct solutions. Okay, finally, looking at question 3, it's a prove that question. So in year 12, we only had 2 trig identities that we needed to remember. We had that tan theta is sine theta over cos theta, and also that sine squared theta plus cos squared theta is equal to 1. It's a proof question, so I can only start with my left-hand side or my right-hand side and work down to the other. I can't start with both sides and then do stuff, because I'm just assuming then it's true. As long as I do stuff correctly, I'll end up with another true statement or assumed true statement. So I'm going to start with the left-hand side. So on the left-hand side, we've got cos to the 4 theta minus sine to the 4 theta all over cos squared theta. And the key thing to notice here is that the numerator of that fraction is a difference of 2 squares. And I can therefore write this as cos squared theta plus sine squared theta, all in one bracket multiplied by in another big bracket, cos squared theta minus sine squared theta. And that is all over cos squared theta. So using the fact that cos squared theta plus sine squared theta is 1, this first bracket goes to 1. So we end up with cos squared theta minus sine squared theta all over cos squared theta. Simplifying then, we've got cos squared theta over cos squared theta, and I've run out of space going down, so I will naughtily go to the side. So we get minus sine squared theta over cos squared theta. Well, the first term, cos squared theta over cos squared theta, is the 1. Sine over cos is tan, so sine squared theta over cos squared theta is tan squared theta. So 1 minus tan squared theta, which is equal to the right-hand side as required. And there you have it. That is the end of the third example. So you've got 3 examples to go through, and then we've got some questions that are similar or use similar ideas to these. Good luck with the questions.